All right, today I'm gonna try to fix this. This is some kind of a drive motor off of some kind of an awning on a camper. I haven't actually seen where it goes on the camper, but the problem is that this gear is no longer affixed to the shaft, and it just spins on the shaft. So I've got a couple of options. I could try to make a new gear shaft all in one piece out of steel. That would probably work. If you notice the gear, it's a angle cut gear, so that'd be a little bit not impossible to do, but just a little bit more difficult to match that angle on the setup on the rotary or my indexing head. And then the gear tooth profile, of course, they're really tiny teeth. I'd have to grind a tool and try to match that. Would be, yeah, not impossible, but probably more trouble than it's worth. So what I think I'm gonna do, and I'm not sure yet, is to turn this side of the gear, because the gear sits in here like this. There's a thrust washer and a wave washer on that side. I think I'm gonna turn all of these ridges out of this gear just down to the center webbing, and then even the hub there, turn that thickness completely out of it and get rid of it, and then make a steel hub that will take that space. But if I turn the meat out of the gear and then replace that essentially by putting the steel in there, then the thickness of the gear this way won't be affected. I should be able to match that, and then when I'm done, make a pass cut on that and make this back to the same thickness. And then if I do that, then I can, because this thing's, I mean, it's little, then I can probably come in here and weld that steel hub to the shaft, and then probably epoxy it and set some maybe some small button head screws. They may sit below the surface of this webbing and not stick out on this side of the gear any. So that's kind of the plan I'm going with right now. That may change as I get into this a little bit, and if I ruin it, I will try to make another one. So if I make another one, this shaft is hardened, but it's a plastic gear, and I don't really have a way to harden it other than just heating it up and dunking it, hoping for the best. But I don't really have a good way to anneal it either, other than just with a torch. So anyway, I'm going to try to do this, because it's not going to take a lot of torque to get this thing back up and running. It's not going to be that strong. But I think I'm going to start out at the lathe and do some trimming on this and kind of see how it goes. All right, so here I've drew up a little sketch, made some critical measurements so that my drawing is no good, but the measurements are what counts. And that way, if something happens and I destroy this, I have somewhere to start. I won't have surely there'll be enough pieces left or whatever to get the angle on the tooth and the tooth pitch. But anyway, we'll go to the lathe and see if we can take some material out of this. All right, we're over here at the lathe. What I did here is I put a collet block in here because the collet holds this a lot better. Now this gear is not affixed solidly. It's just, it takes a little tension but you can spin it. So I'm hoping I can take light cuts and still be able to cut it without it spinning on the shaft. But I probably won't be able to film this very good because I'm gonna have to keep an eye on what I'm doing. And if it spins, I'll have to back out of it real fast. So I'll try here and we'll see what happens. So spin her up here. Okay, so that's working. So what I'm gonna do is I'm gonna put the phone down so I can pay attention to what's going on here. But I'm just gonna ease up and just try to keep from touching that shaft and cut it about halfway back this way on the gear. And then I'll rotate my tool, or probably change tools, and put one in here where I can come up against this square shoulder under here and bring the rest of that material out of there. All right, so I have basically hollowed out the inside of this gear, all that webbing out of there, and I believe this gear's got fiber reinforcement in it, which that makes sense. And then I left just, that's just gonna, when I press this off the shaft, that little bit of material right there will just pop right out of there with a deburr knife, and then I can start making my piece to go in here. So we'll start on that. I see. So I don't know, let me get a little light here. If you guys can see it, but there is there's a hollow part through the center of this shaft besides those knurls that when this gear was cast on here, that was cast as part of the gear, those have sheared off, so that's why it's slipping on there. But I'm gonna get this material out of here, start making this piece. I'm gonna this is a little sketch what I'm making. It's just a donut. The OD is 1.880. The ID is 390. This is actually 392. I'm gonna make it 390. I'll probably heat it up and press it onto here, and then once I get it at the right spot, I'll probably gonna weld it in place. We'll see how it goes. And as far as thickness goes, I'm probably just gonna make it a little bit thicker than this, and then do a finished turn on this once it's all assembled and together. We'll see how that goes as well. Alright, I've got a piece of stock stuck in here. I'm going to start by just facing this off square and turning this to 1.880. Touch off. Hold her on lever. And this one-handed. Touch off again. Put it reversed. There we go. The right one that time. Alright, we got a pretty crappy finish that time. I'm going to check out my insert and make another pass on that, see what it looks like. Alright, so we'll whittle it down a little bit, and we're at 156 left to take off of this. So I'm going to dial in another 50 here. Look there. So I got 106. I'm gonna take that in 2 passes. I'm gonna take 50, another 50, and then I'll make my last pass at 55. So, all right. So I nailed my size there. This fits perfect, and there is no wiggle. We're gonna make in the center hole. Okay, so did not have a reamer the right size, so I just had to get the closest drill size and drill it. And so I poked a hole, and what I ended up with was not necessarily a press fit. It's actually more of a slip fit, but it fits pretty good. I mean, just very little wiggle room there. Plenty close enough to weld, and I think it'll work fine. So now I'm going to part this off. All right, so I'm set up for parting here. Air compressor's on, so it'll be loud. But what I've done is I've set my parting tool up. I put this Noga arm on here with a dial indicator, and I just kissed off the outside face of that part with my parting blade. And then I moved the parting blade this way, the thickness of the parting blade according to this indicator. And then, there it shut off. And then I zeroed my indicator. So that puts me, this edge of my parting tool is lined up perfectly with the edge of the part. And so now I'm gonna move back this way, the thickness that I wanna leave my part. And I decided probably against making a final cut. It's not that critical. I'm just going to try to hit the closest thousandth and run with it. So what I've got here measured on how deep that recess is in that gear. It's about 105 thousandths. So I'm gonna move back 105 thousandths. So there's 100 and 5. And now I'm gonna lock my carriage here. So that stops it from being able to move this way or that way. And carding is going to be, it's a two-handed operation because I have to constantly drop oil in there while I'm feeding real smoothly. So I'll have to come back when I'm done with that. All right, I'll try to show you a little bit of this parting. What I'll do is I got to feed oil into it while I am cutting. So parting can be fairly horrendous if you're not careful. Sounds like the old insert's giving it up there. Crunchy down in there. Yeah, that insert don't look very healthy. I'll try the motor on with it though. Cut it off. Picking up any chatter, I'm gonna try a faster speed. Not really any better, but a smaller drill bit in here. Run this up. See if it'll catch my part. It comes off. Maybe out of tool clearance here. There it is. That's going to be very hot. I'm going to let it cool off a minute before I grab it. Alright, there we are. So. Next, we will position this where it needs to go on here. Weld it into place without the plastic gear on there, and then we'll go to the mill and drill some holes for some screws. Alright, so I got the collar made and it's put on there in the right place, and I got a couple of tacks on it. I'm just going to go around it and weld it on there, and it should be a permanent part of it. Alright, so I got it welded on there. I'm going to have to come back on the lathe and trim a little bit of that weld down. Thing's pretty small, but I think there's a bushing that's to right on this outside edge. I welded on both sides. I started on this side. I should have just welded on the other. So to give you some scale, this is a 1/16 inch rod. So alright, here it is after I throwed it back in the lathe and cleaned it up a little bit and dressed down my weld a little bit for clearance. So next step, to the milling machine to put holes to drive the gear. Alright, so I'm over in the milling machine. I've centered up on the shaft. The only screws I have that might work are these really long ones. They're 832, but the heads are pretty short, and they're going to sit down inside those pockets. So hopefully I'm putting this hole, you're not going to see that in the right spot, but I'm going to go around and drill these holes. Alright, I forgot to film while I was drilling holes there. Evelyn came in and was visiting with me, and when she left I just forgot about filming. So anyway, here it is. This is the back side after I cleaned it up, and there's the front side. You can see the bolt pattern and the screws. Should work just fine.